Waterborne systems have been around or researched for many years now. But if we look at the situation today, there are still a lot of solvent-based systems around about 70% of the total consumption is solvent-based. So there's still a lot of technology and market to go after. But now, driven by the legislation, we see that there is a much higher interest for these sorts of systems, and these go now into a variety of applications. And I'm thinking there about water-based systems for general industry applications, for protective coating applications, for decorative applications, and so on. It's not enough just to have a system that is in water. We need to have some very good properties to go with that water-based system, and the legislation alone will not drive people to change to a totally new system for them, certainly given all the investments that are involved. So we are very actively working on properties improvement for water-based systems to make them acceptable to a very broad range of customers. Waterborne UV systems are a very specific niche and application within the waterborne range. They combine the advantages of a typical 100% UV system with water-based properties. If I think about UV-PUD systems, they go into applications like wood coatings, plastics coatings, and so on. What is interesting about a UV-PUD system is that you can decouple the molecular weight of the molecules with the viscosity, so they are very suited for spray applications. And they are today up to a standard where they give some very interesting properties for the markets that they serve. Powder systems have been around for quite some time. They are very interesting because they are almost 100% powder systems with no VOCs at all. And they go into traditional applications like appliances and other sorts of metal coatings. What is new in the powders area is that there's more and more a trend towards low-bake systems which cure at lower temperature, thereby reducing the energy consumption and also allowing substrates that were not possible until now. I'm specifically thinking about MDF, medium density fiberboard, which was not a possible substrate for powders. But now with improved flow and curing properties of powder systems, we can access those sorts of applications. Another example in the powders area is the fact that we can do big metal objects which would otherwise require a lot of energy to be heated up to the traditional curing temperatures, and they can now be used much more energy friendly at reduced baking temperatures.